I'm Anil Kumar. This video is for my student Melissa, who wants to understand position, velocity and acceleration graphs. So we'll have two questions incorporated in this video. Let's begin with the very first one, which is consider position time graph, which is given here. You need to answer all these questions. When is velocity 0? When is object moving in negative direction? When is acceleration 0? When is acceleration negative? And when is object slowing down? Okay, so these are all important things to consider when we look at position time graph. So let's mark some values here to discuss. So we see it's concave up from A to this point, let it be B, and then it turns at C, and then it's kind of, let's put this point as T, correct? That should help us to answer these questions. You can actually pause the video, answer the questions, and then look into my suggestions. So first is, when is velocity 0? So velocity is 0 whenever that slope of tangent is 0, horizontal. Is it okay? So only at point C it is 0. So the answer here is point C. So let me write down the answers on the side. So it is at C. When is object moving in negative direction? Negative direction means distance, decreases, right? Decreases. So here it increases, but from C to D it is decreasing, and therefore it is from C to D, right? So that distance is decreasing, so the object is moving in negative direction. Also, whenever object moves in negative direction, velocity is negative. Is it okay? So if I draw a tangent line, the slope will be negative. So any tangent line during this part will have negative slope. When is acceleration 0? So either it could be a straight line. Here we have curved. So acceleration is 0 at point of inflection. The only point of inflection here is point B, and so B is the point where acceleration is 0. When is acceleration negative? Negative acceleration means we are looking for a curve which is concave down. So you can see from B to D it is concave down. So we can say from B to D, so BCD, right? So that curve is the region or interval where acceleration is negative. The last question here is, when is object slowing down? So when is object slowing down? How do we get from the given figure? Now, object slows down when so let's write down when object slows down. Object slows down when acceleration times velocity is less than 0. So that means they have opposite signs. Is that okay? So that requires some analysis on this particular graph. Okay, let's do that. So this is a huge question. Okay, let's try to understand now. When does it slow down? Okay. So we'll have to figure out where is velocity positive. As you can see, velocity is positive. So let me make, I'm just thinking how to explain this. Okay, so what I will do here is I will write down where velocity is positive and where acceleration is positive, right? So from A to, so let's write down portions like A, B, C and D, right? A, B, C and D. So we see that from A to C, velocity is positive. Is it okay? So we'll say, let me use velocity V and acceleration A. So from A to C, velocity is positive in this portion. But from C to D, it is negative. This is about velocity. As far as the acceleration is concerned, it is concave up in this portion, right? A to B, it is concave up. That means acceleration is positive, right? From B to D, it is negative. Now when we say, when is the object slowing down, in that case, they should have opposite signs. So the only opposite sign combination which you get is in this portion, B to C, right? So B to C is the portion when the object slows down. Is that clear to you? Right? So the answer here is from B to C. The object slows down. So you have to analyze both velocity and acceleration to answer such a question, right? So I hope you find it interesting. Let's move on to the next graph now. Okay, so here we have another curve, which is also a position time graph. You need to answer the same 5 questions. When is velocity 0? When is object moving in positive direction? When is acceleration 0? When is acceleration positive? And when the object is speeding, this time speeding, okay? So you can pause the video, answer the question, and then look into my suggestions. So for 0 velocity, we are looking for tangents to be horizontal. So it is, okay, let's first number. So A, B, C, D, and E are our points. So velocity is 0 at, you can see clearly, C. When is object moving in positive direction? Means going away, right? So it is from C to E. It is from C to E. Is it okay? Now, when is acceleration 0? We are looking for point of inflections, which is B and D, right? So it is B and D. When is acceleration positive? Positive means concave up, so it is BCD. So it is BCD. Is that okay? So that is concave up, right? Let me draw like this. So this is concave up, where acceleration is positive, right? So A is greater than 0. In other portions, A is negative. Now it says, when is object speeding? That's interesting part, which we'll discuss now. For speeding, both acceleration and velocity product should be same. And when you multiply, you get something which is greater than 0. So that is the strategy. Okay? Now, in this diagram, you have to figure out where the velocity is positive, where is acceleration is positive, and where are they negative. So let me write down. Here the acceleration is negative, here acceleration is negative, and use another ring to write velocity. So as you see from this portion, since if I draw a tangent line, velocity is less than 0, velocity is less than 0. It is 0 here, but then it is positive. So in this portion, so what we have here is, let me extend here, let me extend here and then do. So in this portion, velocity is greater than 0, right? In this portion, velocity is greater than 0. Correct? So from here, we can easily see, you see both of them are in the same direction. Velocity is less than 0, acceleration is less than 0. That means this is speeding, right? So it is, let's write this, speeding. So when is object speeding? A to B is first answer. Is it okay? Now, in this portion, velocity is positive, acceleration is negative. So this is slowing down. But here, from C to D, both are greater than 0. So again, speeding, right? So we can say CD, right? CD. Both are positive. And in this portion, acceleration is negative, so it is slowing down. Is it okay? So we found 2 answers. One speeding in this interval and the initial interval. So that is how I hope you could answer speeding and slowing down also from a given position time graph. I hope you find it interesting. Feel free to post questions. That helps me to get to you excellent material. Share and subscribe my videos, and if you like, that'd be great. Thank you and all the best.